Okay. Hello. I'll be like showing you how I solved this problem. So okay, let's get to it. So the first thing I do is to like identify what we have here. So like, all right. So what it's asking for. Okay, first we gotta see what's given. So a pool ball leaves 60-meter high table with an initial horizontal velocity of 2.4. Pick the time required, I mean, for the pool ball to fall the ground, horizontal distance. Alright, so let's break this down. We have the we have the 0.60 meter high table, and since it's like meter high, it's talking about like this and not like that. So like this, but no, like okay, like that. So because it's high, it's talking about the vertical. So we have 0.60 meters as our y-axis, or like vertical um, thing. Next we have the initial horizontal velocity, which is going to be vx, because x, like the x-axis, 2.4, like that. So what the question is asking for is for the time, and for the horizontal distance, which is gonna be, well, distance. So distance x, because we have distance y, which is the high table. Distance x is gonna be how. Okay, I'll illustrate. So the pool ball leaves a 60-meter high table. Let's pretend this is the table, and it's 0.60. The ball is there. So this is 0.60, and then it jumps from the at a velocity. It has 2.4 meters. So what it's looking for is how long it takes for the ball to reach the ground, and what's like the distance, because this is just the velocity but not how much the ball goes from the table. So what now is we should use these formulas. So first of all, we need to look for time. So I will just this one. Wait, this one. Okay. And note that g is always negative point. This is not the velocity, but it's actually the acceleration. So take note of that. But velocity is constant. So remember. Actually, no, I think it is the. I don't know. See, it's not the velocity, guys. It's the acceleration. Okay, so t, we're gonna look for the time. T is gonna be our time, and we're just gonna copy the formula here. So it's gonna be squared, maybe root or whatever it's called. So 2. We have to put dy, the distance y, which is our 0.60. So basically, it's 2 times 0.60 over g, which is our gravity, 9.8, negative 9.8. So, you can try to do like all of that at once, but it might break your calculator. So I'll just break it down to more like easy and manageable pieces. So, 2 2 times 0.60 is 1.2, and we're just gonna put the 9.8 there. So we're gonna divide these now, and dividing that gives us 0.122. I just simplified it. There's more numbers, but I just, rounded off to the nearest. So Anyways, 0.2. Now don't forget we still have to square this. Square to the root it. We have to do that thing. And that gives us 0.35. I'm not sure if that's, wait, is that the exact one? Okay, again, I just rounded this off. But that's what we got, 0.35. So that's the time. 0.35 seconds. Unless stated otherwise, it's always going to be in seconds, as that's the default. Okay, so we got our time, and now we just gotta find the x. So it's just simple multiplication. We just times the velocity x with the time, which is 2.4 times 0.35, and that gives us 0.84 meters. So I'm gonna recap. What we did was we analyzed the problem. We took what was given, and with our knowledge, we took what was given, which is the 0.60 meter high table, with the horizontal velocity of 2.4, and we know that a g is always negative 9.8. So that gives us our stuff. Use the formula here, and we just I forgot the word, but we just put in what the formula tells us to. Like, since it asks for dy, we just put dy in the formula like that. But as for g, we put g there. We do that, we do the formula stuff, we get our answer, and we do the same thing for there, and we get boom. Thank you guys.